Hi everyone. So again it's Hiral Shah and I'm here to conduct my today's session. And as we have discussed that in our next session we will start with the limit topics, right? And before starting our today's session, let me give some highlights of our previous sessions. So previously we did little bit of chapter chapter outlines yani ki little bit of topics that we are going to study in our main topic yani ki in analytic functions, right? And then after we just started with the representation of the examples, representations of the complex numbers, that how we can represent, how we can separate into real as well as into the imaginary parts. So let's start with our today's session, and in this session we will do some examples of limits, and before this we will discuss the analytic functions, that what is analytic functions. So let's start guys. And here I have given the analytic functions. I have given here some of the definitions regarding analytic, that what is analytic. But in the details we will do in the examples of analytic only. Okay. So right now I'm just giving just some of the definitions of the analytics. So for the analytic function, a single valued function which is defined and differentiable at each point of a domain D is said to be analytic in that domain. So particularly with this we'll understand the examples. Okay. And second one is given the definition of analytic at the given point. It means to find analytic, that there will be given one point. Okay, so for some specifically point we will find this, we will solve this example. So for that the definition is given: a function is said to be analytic at a point if its derivative exists not only at that point but in some neighborhood of that point. It means for that which one is necessary component, which one is derivative, its derivative should must be exist, but not only at that point जो आपको क्वेश्चन में दिया है वो सिर्फ वो पॉइंट के लिए नहीं, बट इन सम नेबरहुड ऑफ दैट पॉइंट, यानी कि suppose it's given an interval for 0 to 6, then maybe it will be not possible for all the points like 0 1 2 3 4 5 or 6, maybe it's not possible, but that will be uh, uh, 2 or 3 points at that it will be possible. Okay. And it's given singular point, the point where the function is not analytic is called. So to be a singular point the function should not be analytic. अगर वो analytic नहीं है then we can call as singular point for the specifically function. In details guys we will do in the example, so that at that time you will get more knowledge regarding these definitions. Okay. Now let's start the examples of the limits, and to उसकी definitions मैं आपको इधर ही समझा दूंगी, that how and what we have to find to show the limits, if limit exist or not. Okay. तो उसके लिए हमें क्या चाहिए और what we have to prove, what we have to show, that we will discuss in the examples directly. So I'm not giving its definition. So see the question, यहाँ fourth मैंने लिखा है, but do with don't go in this examples, don't go in the number. Okay. The question is given, show that the limit of the function does not exist. Okay. So here you can see it's given a question type of the limit examples. So it will be into the like f of z equals to the one function will be given, and it is given in the form of z square, and the second one is given 0 for z does not equals to I, and this one z equals to I. So definitely the question type of the limit examples will be in the form of like this way. Now what you have to do, you have to apply this limit, always this one, एज लिमिट z टेंड्स टू i f of z, यहाँ पे जो भी फंक्शन है दैट यू हैव टू राइट एंड उसको आप उसमें आपको लिमिट अप्लाई करनी है, ठीक है। सो द लिमिट z टेंड्स टू i f of z equals to limit z tends to I, the value of f of z, and that will be the functions which will be given into the equation, and this is given in the form of z square. Okay, now in place of z you have to apply its limit. Okay, see guys, always it will be given two functions. One first one will be for not equals to, and second one will be for that particular points. Okay, so here it is given z does not equals to y, and the second one will be it's given for z equals to I. Or sometimes it will be like z does not equals to 0 and z equals to 0, or else it can be possible z equals to -1 and z equals to +1, sorry, z equals to -1. Okay, so maybe the question format will be like this, and at the last you have to put the values of z for this particular functions. Okay, so I'm putting I square, and I square equals to -1. But it's given for the I, if we will put I, then the function must be 0 form, right? But here you can see that here we are getting -1, this one is not being 0. So if this one will be 0, okay, again I'm highlighting with yellow marker. See, again it will be, if it will be 0, okay, then we can say that the limit is exist. But as you can see here, we have applied z tends to I limit, yani ki we have applied this limits, right? And for this you can see the function should be 0 form, but here we are not getting, so we can say that the limit does not exist. So hope you all understood guys. And based on this we are going to solve some more examples. And here the question is given, show that limit z tends to 0, z upon z bar does not exist. See, here it's given directly functions, but you can imagine that the function will be in which type, right? It will be same type of first example, because here it's given z tends to 0, yani ki first one will be for z does not equals to 0, and the second one will be z equals to 0, and the function is given z upon z bar. So that we can write here f of z equals to z upon z bar. Now applying limit on both these sides, right? So limit x z tends to 0, same here limit z tends to 0, and putting the values of z we can get x plus iy, x minus iy. Okay, now here you can see the limits is given z, and here you can observe the components are given x and y both. Okay, so definitely z yani ki they are having two functions x and y, because z is what actual x plus iy. I'm writing here guys, what is z? This one will be x plus iy, right? And same here the function is given into the that one, yani ki z plus iy form. So here it's not given any single variable, so you can't put limits directly, right? Because हमारे पास यहाँ पे z के दो कंपोनेंट्स है, यानी कि दो की लिमिट्स है हमारे पास, सो हम दोनों लिमिट्स एक साथ पुट नहीं कर सकते हैं, एंड एक्चुअल z इज गिवन x plus iy. Okay, so for that you have to apply one case for that. For each components you have to apply one line, यानी कि y equals to mx. One path आपको apply करना है, and this method we have studied in our first and first semester, I think, right? Sorry, in the partial differential equations, and maybe it was coming in the first sem, right? No, in the second semester, yes. So वहाँ पर भी हम लोग यही कर रहे थे, that was I think 7th or 8th method, limits and continuity, as you know all. So same ही आपको apply करना है. So I'm applying here the line y equals to mx line. Okay, so that y equals to mx, यानी कि हम लोग यहाँ पे लिमिट्स अप्लाई करेंगे y की, यानी कि mx tends to the 0. But as you know all, m is your constant number, so that we can get x tends to the 0. So that's why I have written here x tends to the 0. And here x plus I, in place of y definitely we will put now mx. Yes, now from the numerator and denominator you can see this one is common term for both. So I'm just cancelling out this x, so the remaining term will be 1 plus im and 1 minus im. I think this one is little bit have cut, so I'm just writing, yes, so 1 minus im. So now put the limits, in place of x you have to put 0, but here you can see that, you can observe that here it's not given x. It means this one will be as it is now, and to be to show the limit exist, okay, it must be 0 form, but as you know this one is not being 0, so definitely the limit does not exist again. And see, I have written here, since the limit values depends on m, it takes different values along different paths, so hence the limit does not exist. Now next one is given, show that limit z tends to 0, 3x square plus y square upon x plus y whole square does not exist. So again you have to prove this one does not exist. So definitely it will be not a 0 form, okay. I mean you will get some kind of numbers or constant, etc. So definitely here it's given a function z, and here the function is given in the form of x and y both. So of course we have to apply one path, and I'm applying here y equals to mx line. So again I'm writing here, guys, y equals to mx tends to 0. Okay, so as m is constant, so x tends to the 0 form, and here in place of y you will apply y equals to mx, so it will be m square x square, and giving some simplification you will get this one term 3 plus m square upon 1 plus m whole square. And now in the place of x you have to put 0, but here you can observe that it's we are not getting here x, okay, so definitely this one will be your final answer. And as you can observe, to be the limit, to exist the limits, this function should be in terms of 0 form, and here you are not getting 0, right? So of course the limit does not exist. So here we did 3 examples regarding the limits, and these one topics I'm going to complete here. There are little bit 2 or 3 examples that but that we will do in our in the differentiation method, okay, or else in the continuity of the functions. So till then please just do the practice of these all the examples, and now we will start again one more new method in our next session. So till that, plus please do the practice. Thank you guys.